Welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to teach you how to solve an equation that has two variables. So there are three ways that I'm going to show you how to do this: substitution, elimination, and graphing. So substitution, what is substitution? Well, if you saw my video on it, it is when we have this one variable isolated by itself, and then we can plug it into another equation. So we have this y by itself. So y equals 6x minus 2, and the other equation is 12x plus y equals 34. What do? Well, we take this y and we do 12x plus, insert the y, which is 6x minus 2. The coefficient was 1, so we don't need a coefficient there, equals 34. And as you see, y is now eliminated, and we can solve for x. So let's just add these. 18x minus 2 equals 34. 18x equals 36. Divide by 18 on both sides, and you get x equals 2. Now, we are not done. What we have to do is we have to plug x into one of these equations. And I'm just going to straight up plug it into this equation, just because it already solves us for y. So now we substitute again. Y equals 6 times 2, because x equals 2 minus 2 will be y equals 12 minus 2. So then y equals 10. So our answer is 2 comma 10 to this solution. Well, this is our solution, 2 comma 10. Next, let's move on to elimination. Elimination here, we don't have a variable by itself, so we have to cancel the variables in this equation somehow. So what we are going to try to do is we are trying to get these equations to have coefficients of one variable to be the same. So here I'm looking, I see 2y and 5y, which I could get easily to 10y as a least common denominator, which would mean I'd have to multiply the top equation by 5. Or there's 3x and 9x, and I see, well, 9x is a pretty simple one, so I don't have to multiply this bottom equation by anything, so I'm going to go with 9x. So this top equation has to be multiplied, all of it, by 3. So we go 3x times 3 is 9x, 2y times 3 is 6y, and 6 times 3 is 18. And then we just move this equation over. 9x plus 5y equals 16. Then what we're going to do is subtract these equations, because 9x minus 9x would get rid of the x. So we subtract these equations from one another. Now we have 0x plus y equals 2. That's 0x. Well, that's not even a thing. That's 0x. Y equals 2. And now this is where substitution comes in handy. We're going to substitute y equals 2 into an equation. I'm going to just plug it into this. 3x plus 2y equals 6. So 3x plus 2 times y equals 6. Y is 2. 3x plus 4 equals 6. Move the 4 over. 3x equals 2. And then x equals 2 thirds. And you could always check that by plugging it back into this. So like 3 times 2 thirds is 2, plus 2 times 2 is 4. 2 plus 4 is 6. Now let's move on to our last whiteboard of graphically. Now, we have two equations here. One is already in y equals form. And now there's one that is not in y equals form. This can be done with all types of equations, with a square root function, with a quadratic. I'm just using lines in all these equations because it makes it a little bit easier and quicker to go over. So we have our two little tables. We have our graph. Y equals 3x plus 4, and 3y plus 6x equals negative 3. Let's get the second one into y equals form. So move the 6x over, 3y equals negative 6x minus 3, and then divide everything by 3. Y equals negative 2x minus 1. Now, let's fill in these xy tables. Let's just start at negative 2 and go from there. If you plug in negative 2 to this y equals 3x plus 4, we are going to get 2. Negative 1, we're going to get 1, 0, 4, 1, 7, 2, 10. Right? So now we can graph those. Started our negative 2, 1, 2, 1, 2. Negative 2, 2, negative 1, 1, 0, 4, 1, 2, 3, 4. I definitely graphed one of those wrong. 1, 7, 1, 2, 3, 4, 5, 6, 7, and then it'll keep going. Which one was this? Negative 2. You plug in negative 2, you're going to get negative 6 plus 4. Negative 2, negative 2. That was my fault. Negative 2, negative 2. 1, 2, 1, 2. Now, if you plug in negative 1, you are going to get 1 back. That, again, was my fault. So, that is our graph. Now, let's graph the other one. Let's start again at negative 2, and then just go on to 2. So, y equals negative 2x minus 1. We plug in negative 2 is then 4 minus 1 is 3. Negative 1 is going to be 2 minus 1 will be 1. 0 will be negative 1. 1 will be negative 3. And 2 will be negative 5. So negative 2, 3. 1, 2, 1, 2, 3. Negative 1, 1. 0, negative 1. 1, negative 3. And 2, negative 5. So now we graph and we see this intersection point. Again, this can be done with quadratics and lines. Quadratic, quadratic. Whatever you need done. Square root. Absolute value. It can be done. We're just using lines here as simple examples. Here, we see that these two intersect at a point. So there is a solution. And since this is a whole number solution, we can just see it when we're on a graph. If it's not a whole number solution, you are not going to want to graph. If it has a fraction in it, do not graph. Like if the solution you can see will be a fraction, just don't graph it because it's not going to help you. So we see negative 1, 1 is our solution. And also if we look at our table here, negative 1, 1 in this first equation and negative 1, 1 in the second equation. So our solution is negative 1, 1. Well, thank you for watching my video on solving equations with two variables. I hope to see you again soon.